Fuel economy estimates for automobiles built in a certain year predicted a mean, an average, of 24.8 miles per gallon and a standard deviation, that's average distance from the middle, of 7.2 miles per gallon for highway driving. Assume that the normal distribution can be applied. Within what range are 99.8% of the automobiles? Okay, well, what they're referring to is this curve right here. So this is not in your homework problem, but I just pasted it here so you could see it. This is from your textbook, actually. I just copied it out of your textbook. This is what we call the normal distribution, the normal curve. Now, why we call it that is because that's what normally happens. We really mean it just like that word. Statisticians over the years, especially Carl Friedrich Gauss was the first one anyway. You don't care about that, but let me get on. So saw that tons of things that occur naturally occur so in a normal distribution. What that means is, like, if you were to just go out and grab leaves off the lawn in the front of the school, you collect 1,000 of them and measure their weight really carefully on the scales in the chemistry department to get really exact. You'd find some average. See, this is average right here. See the X bar? That always means average. When there's a bar on X in statistics, that always means average. That's the middle. There'd be some average leaf weight. I don't know what it is. Maybe it'd be 10 ounces. I'm totally guessing. Maybe the average weight in Fresno State weighs 10 ounces. Okay. So, but they wouldn't all be average. There'd be some heavier ones, some lighter ones. Basically, see the big hump here in the middle? And the 34%, that means 68%, right here, 68% of all the leaves would be right around the middle. They're close to the middle. They're close to average. And now what are these lines here? These lines are one standard deviation. See how they're writing it right here? Standard deviations. So what we mean is from here to here, right, this is the middle, this is the average weight of a leaf, for example. We could do the same thing for the average weight of the men on campus or the average man's shoe size. Anything that occurs naturally. IQ. So not just stuff with people, but like I said, leaves, the length of the blades of grass, on and on and on we go. This is what statisticians discovered, that virtually everything that happens naturally does like this. This is the normal distribution, meaning there'd be some average. Maybe the average man's shoe size is, I don't know, is it 9? Average man, I'm just guessing. And then there would be some, but not every man's average, right? Some have bigger feet, some have smaller feet. Maybe the standard deviation is 2. So this jump would go up to 11 and down to 7. If that's the standard deviation, I'm totally guessing, +2 and -2, meaning, remember what standard deviation means. Standard is typical distance from the middle. Meaning, maybe for men, the average shoe size is 9, average men's shoe size is 9. I'm totally guessing. I have no idea. You could type into Google probably and find the average man's shoe size in the United States and get a number more accurate than I'm giving you. But let's say it's 9. But not every man is average. Some have bigger feet, smaller feet. How far? Some have really big feet. Some have feet that are just a little bigger than average. Some have really small feet. Some have feet a little smaller than average. How far are they off of the middle? Typically, that's called the standard deviation for the men's shoe size. Maybe it's 2, meaning the typical man is 2 shoe sizes off of the middle. That's what standard deviation means. Typical distance from the middle, average distance from the middle. Again, not everybody's middle. Some are above, some are below, some are way above, way below, little below. How far are they from the middle on average? That's standard deviation. So, getting back to this normal curve, if, say, the standard deviation is 2, the average man is off of the middle by 2. So the average shoe size is 9, but not everybody's average. Typically, they're off of the middle by 2. So that would go one standard jump above the middle would put you at shoe size 11. One standard deviation jump below the middle would put you at 7. If that was the case, and you could easily find that on Google, just type in average man's shoe size in America and standard deviation of men's shoe size in America, you get some numbers. That would mean you would know very precisely that 68% of all men in America would have shoe sizes between size 7 and size 11. Very important if you're going to operate a shoe store and you need to know what sizes to stock. Now, let's do it again. Every one of these lines is a standard deviation jump. See, 1, standard deviation 2 and 3, same thing as 1, 2, and 3 the other way. These are all standard deviation jumps. So this would go back by another 2 more back, so this would be to shoe size 5. And this would go up by another 2, and this would be to shoe size, 13, 13. So that would mean then between shoe size 5 and 13, you'd have 95% of all men in America. So if you go if you have the middle, which is shoe size 9, and you go 2 jumps below the middle to 2 jumps above, 2 standard deviation jumps above the middle, from shoe size 5 to 13, you would have 95% of all men. This is almost exact. That's what statisticians found out, and it's very surprising that these numbers work so darn precisely. That between 95, that if you find something is normally distributed, the way things are normally distributed, bell curve, they call this a bell curve or the Gaussian curve. Leaf weights, men's shoe sizes, the size of, the diameter of our ears, on and on you go. Pretty much anything that occurs, IQs, SAT scores, on and on the list goes. This is used everywhere in the world. Things are normally distributed, which means they have a middle, and then they have a standard deviation jump, the typical amount they're off the middle, and if you go 1 below to 1 above, you will grab 68%. These are the most important numbers, these right here. If you go 1 below to 1 above the middle, you're going to capture 68% of all the whatever, all the men, all the leaves, all the whatever. If you go 2 jumps below to 2 jumps above, 95% of all the leaves or all the men's shoe sizes are going to be in that range between shoe size 5 and 13. Now, if you go 3 below, this would be down to shoe size 3, right? 2 more down, and then go up to shoe size 15. You're going to capture from shoe size 3 to 15, 3 jumps below the middle to 3 jumps. These are people that are extreme. If you're 3 standard amounts below or above the middle, you're extreme. You're like, if you have shoe size 15, you're like NBA, right? So you're going to capture 99.7. Now notice it says 99.8 right there. I don't know why Math Excel changed that number. It's really 99.7, but we'll just go ahead and not sweat it. We'll just go with the number Math Excel's using, 99.8%. It's really 99.7, but close enough. Almost 100% of all the men's shoe sizes would be between 3 and 15, because there are 3 standard deviations, 3 typical amounts above or below the middle. All right, so let's get back to the question now that we understand what a normal curve is saying. So they are asking on this question, the mean is 24.8. So let me get rid of all my tons of scribbles on this thing. And, whoops. Okay, so if the mean, the middle here, is 24.8, they're telling me that's the mean, that's the middle, this is the mean, the average right in the middle, and the standard deviation is 7.2, that means from line to line we go up, and if we go this way we go down by 7.2. That's the typical amount, right? So the average car gets 24.8 miles per gallon, but not every car is average. Some are better, some are worse. How far are they off of the middle typically? Typical distance from the middle, standard deviation, 7.2. So typically they're above or below that middle by 7.2. Some are more, some are less, but that's the typical, the average, the standard deviation from the middle. For highway driving, assume that the normal distribution can be applied. Within what range are, I can't read this anymore here, 99.8%. So if you want 99.8%, this is supposed to be the 99.8 here. You got to go 3 jumps below to 3 jumps above. So So you got to go down 7.2, the standard amount, 3 times. And you got to go up 7.2 3 times in the other direction. So if you take, so that means this spot right here is 24.8 minus 7.2 minus 7.2 minus 7.2. That's what this spot equals. I don't know what that is. I'm going to take my calculator. So you can just take 24.8 minus 7.2 times 3, and I'm getting 3.2. So this line would be 3.2, right? You could have just done all 3 steps. You could have just taken 24.8, the middle, subtract 7.2 once. This line is 17.6. Subtract 7.2 again. This line is 10.4. Subtract 17.2 again, and you get 3.2. Now let's go the other way. So that'd be the low. You're between 3.2, and now let's go up. So I'm going to add 7. I'm going to take 24.8 and add 7.2. I'm adding the standard amount. Puts me at 32. Add 7.2 again. Puts me at 39.2. Add 7.2 one more time. Puts me at 46.4. So there's where we're at, 46.4. Meaning, so that's 3 jumps above. 3.2 is 3 jumps below, which captures 99.8% of the data. Why did we do 3? Because this is the number, or really 99.8, that they referred to, which is 3 jumps below to 3 jumps above. So in other words, the range for automobiles, so 99.8% of all, which is almost all automobiles, almost 100% of automobiles, are going to have a miles per gallon somewhere between 3.2, yeah, you can't be much lower than that, and a high of 46.4. I guess there's a couple of really economical cars that are better than that, but that captures almost 100%. So that's what we do whenever they refer to the normal curve. We look for these 3 numbers. 68% means 1 jump below to 1 jump above the middle. You just find the middle and subtract or add the standard deviation amount. 95% is 2 jumps below to 2 jumps above, and 99.8, 3 jumps below to 3 jumps above.